Today we are going to talk about powers and exponents. Your goal by the end of this lesson is to be able to write and evaluate numerical expressions that involve whole number exponents. Now, before we get into vocabulary word, I want to make sure that you understand that exponents, writing something in powers with an exponent, is a simplified way to write multiplication. When a number is being multiplied several times, this is a simplified way to write it. So it's indicating multiplication. All right, so let's get into that vocab. We've got a diagram down here to take a look at while we go through our vocab words. Let's start with power. So your power is right here, that combination of your bigger number, your normal size number, and that little bitty number. Okay, so this right here is your power. It's your product of your repeated factors. Your power is broken into two parts. Your base, which is that regular sized number, and this is the number that will be multiplied together. And then the other part is your exponent, and your exponent's the little guy up at the top right. When you write an exponent, you want to make sure it's less than half the size of your base and up to the right. This exponent here tells us how many times our base is going to be multiplied together. So in this case, our base is 5, so we multiply the 5 together 3 times. Okay, so again, your base is the one that's being multiplied, and the exponent tells you how many times to multiply. So let's take a look at a couple of different forms that we can write those exponents in. So first we have our exponential form. When we write something in exponential form, we've got that base and we've got that exponent up top. We can also write this or say this in word form. So we would read this in this exponential form as 3 to the 4th power, or 3 to the power of 4. If we were to expand it out, we would multiply our base the number of times the exponent tells us to. So we've got a base of 3, and that 3 gets multiplied 4 times. So expanded form would be 3 times 3 times 3 times 3. Standard form is what we get when we multiply those all together. And that in this case would be 81. And I will show you how to get that in just a moment. So we've got several different types of problems that we are going to try today. And we are going to make sure that we read our words appropriately. So example 1 asks us to write each product as a power. So this is also meaning that we are going to write it in exponential form. We want to write it with that base and that exponent. Here it's expanded. We want to simplify it down as a power into your exponential form. So we start with the number that we're multiplying. That will be your base. We've got 6 being multiplied. That's our base. Then I look and see how many times that number is being multiplied. Here we've got 1, 2, 3, 4. So our exponent will be 4. This 6 times 6 times 6 times 6 translated to exponential form is 6 to the power of 4. Let's try one more example here. We've got 9 times 9 times 9. Again, the 9 is what's being multiplied, so that's our base. Because it's being multiplied 3 times, our exponent will be 3. All right, so we've got 2 example problems down here. Why don't you pause the video and try those now? All right, so as you hopefully saw, this would be 3 to the power of 6, and this would be 10 to the power of 4. All right, we've got 2 more types of problems that you will encounter. The first one is when you need to find the value of that power. So that means you need to write your your power in standard form. And you need to do that by starting with expanded form. So take a look here. If I have 2 to the power of 3, I'm going to expand that out. So it looks like 2 times 2 times 2. Now, you can do that in your head if you would like, or you can, kind of like an order of operations problem, you can solve it part by part. So, for example, I'll start here, 2 times 2. 2 times 2 is 4. And then I multiply that 4 times 2. 4 times 2 is 8. So 2 to the power of 3 in standard form is 8. All right, let's try another example here. We've got 12 to the power of 2. So I write my base out, the number of times my exponent tells me, and I evaluate that expression to be 144. So 12 to the power of 2 equals 144. When we've got that little 2 up there, we can also read that as squared. All right, so we've got 2 more practice problems here. Why don't you pause the video and try those yourself? Okay, so hopefully you got 343 for 7 to the power of 3. And 5 to the power of 2, we get 25. All right, we've got one more type of problem to practice down here. And this is perfect squares. So perfect squares are numbers that are multiplied together twice. So if we were to make a list of perfect squares, we would have 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 equals 16. These numbers, 1, 4, 9, and 16 are your perfect squares. So as you continue, your perfect squares are 2 numbers that are multiplied together. So 10 and 10, 17 and 17. So this list continues on. So we have to determine what factors these numbers have and if a number multiplied by itself will get us these numbers. So I think about the factors of 81 and I come to 9. 9 times 9 equals 81. Therefore, it is a perfect square. 81 is a perfect square. A number is multiplied by itself one time. To get us that number, it's perfect square. If I think about the factors of 22, 1, 2, 11, and 22, none of these multiplied by itself, nothing multiplied by itself will get us 22. So this is not a perfect square. Why don't you go ahead and pause the video and try these 2 here. So 30 is not a perfect square, and 64 is a perfect square because if you multiply 8 by itself, 8 squared, or 8 times 8, you will get 64.